Hi everybody, welcome to Video Notes 1B1C. We're going to talk mass, matter, density, and let's get going. All right, so what do you get when you mix sulfur, tungsten, and silver together? Swag, boom. All right, so here's the two objectives we're going to be covering. So make sure when we're done, if you look at those, you have a good idea of how to do those things. All right, so you are my density. Chemists study matter and they have to describe it using properties. Density is a property that distinguishes different kinds of matter, and the definition of density is mass per unit volume. So here's some objects, and here's their density, and notice the units are grams per centimeter cubed because you have to compare the mass to the volume. So how much stuff it has compared to how much space it takes up. Things with different densities will go different places if you put them together. Things that they're the most dense will be on the bottom, and the least dense will be on the top. Okay, so it's a physical property that's the mass per unit volume. Here's the formula for it, and we can write that as D for density equals M for mass over V for volume. So what kind of units will density have? Well, the mass has a unit of grams, volume has a unit of milliliters, or it could be centimeters cubed if we're talking about solids. So density has to have both of those units, so it's going to be grams per milliliter or grams per centimeter cubed, but it could have any units of mass and volume. And so if you know the density of a substance, you can know if it'll sink or float in another substance. So water has a density of 1 gram per centimeter cubed, or 1 gram per milliliter is its density. It means the same thing. So if something has a density bigger than 1, it's going to sink in water. If something has a density less than 1, it'll float in water. So how do we get the mass? Well, we get the mass using a balance. Get your mass here. All right, get your mass using a balance. Get your volume. Volume is the amount of matter something has, but volume is how much space it takes up. So all these cubes have about the same volume. They take up the same amount of space, but they have more. Some of them have more stuff in it than others. So the more density something has, it means there's more matter in the unit volume. Okay. So one unit that we use for volume is milliliter, right? Milliliter. So see, this is 1 milliliter here. That's 1 milliliter because there's 10. So this is 1. If we took a cube and measured it 1 centimeter on each side, so like a little sugar cube or something, when we poured water into it and then poured that water into here, 1 cubic centimeter of water would take up 1 milliliter of space in a graduated cylinder. So 1 cubic centimeter equals 1 milliliter. And now sometimes, and then if you listen to those TV shows where they have the doctors and they're like, give me 1 cc of blah, blah, blah stat. They're saying, give me 1 cubic centimeter, so they want 1 milliliter. So now you know what that means. Yeah, you're on your way to being a doctor. Okay, so how are we going to find density? We're going to find the mass of a substance using a balance. Use a balance. And then we're going to find the volume of a substance. Now, if the substance has a regular shape, we can measure the side, and then volume is side times side times side. So volume equals side times side times side. In this one, the volume is 9. I'm going to change it to centimeters because we're going to use centimeters. So 9 centimeters times 9 times 9 would give us the volume of this cube. Okay. Now, not everything's a regular shape. So in order to get the volume, we could see how much space it takes up when we put it in water. Okay, so that way you have to put some water in a graduated cylinder. Okay, this is how much water there is, 200 milliliters. Then you put the object, which has an irregular shape, into the graduated cylinder, and the water goes up because that takes up some space. So the amount of space that takes up is the amount of this difference the water goes up. So then you put the object in there, and it goes up to 260. So then you would say, well, the space that the object takes up is 260 minus 200 milliliters. So the volume of the object is 60 milliliters. Okay, so find the mass using a balance, and that's going to be grams. Find the volume using measuring the sides and multiplying, or Or if it's a cylinder, you'd use volume of a cylinder, that kind of stuff. But water displacement is this technique where you put the irregular shaped object and then you have to subtract what it is with the object in it minus what it was before the object. Okay, and that's going to be centimeters cubed or milliliters. All right, so the other thing about density is that it has a linear, mass and volume have a linear relationship. If the mass goes up, the volume goes up. And so you could calculate the density using the slope of a line. All right, so the rise is the mass. All right, so this is how much, this is the rise, and this is the run. And so density equals mass over volume. So the slope of a line will have density. Can help find density. Yeah. All right. And so this object is, or a certain substance, so each substance has its own density. Each substance has its own density. Has its own density. Okay. All right, so that was density. Density is a property of matter. And then we're going to look also try to learn about what mass and change, the relationship between mass and change. Okay, so during a chemical or physical change, mass stays constant, but matter can change form. Okay, this is known as the law of conservation of mass. Mass stays constant, but matter changes form. So here is a block, right? A block. That's going to change, and these are smaller pieces. Block cut up. If we weighed it before, say, and it weighed 10 grams, then after we cut it up, it would still weigh 10 grams. All right? Because even though it changed, its identity didn't change, which is a physical change, and its mass is not going to change. You just have to get all those pieces back on the balance to see 10 grams before, 10 grams after. So mass doesn't change when a physical change occurs. Okay, same amount of mass. All right, here's a chemical reaction. Chemical reaction. That's a chemical change. All right, so before the chemical reaction, these things are equal, right? After the chemical reaction, the mass here is still balanced, still equal. Okay, so this is before, this is after, but mass. Say the mass was, I'll use a different number, 14 grams, because that's what it weighed here. Then after the reaction, how much should it weigh? If you're saying 14 grams, you are right on. Way to go, peeps. It's called the law of conservation of mass. In a chemical change, you should be able to account for all of the mass, even though it changes form into a different form. It's not changing mass. Physical change. It changes still the same substance. This might be a new substance, but still the same mass. This is the same substance, but different shape, different kinds of pieces, but the mass stays the same. Okay. All right. So let's practice using the things we know about density to do some calculations. So an object has a mass of 10 grams. So I'm going to list out my variables. My variables. M equals 10 grams. So when we're problem solving, we should list out what we know. The volume is 5 centimeters. V is my symbol for volume cubed, 5 centimeters cubed, 5.0 centimeters cubed. All right, what is the density? Density is what we're trying to find. So I'll put question mark. If you want to put X, that's fine. These are things we're given, so I might call them are given, and this is what we're trying to find. It helps to sort out what the problem's asking. So I know my M and my V. I'm looking for D. What are we trying to find? Density. Write it down. I know it says it here. You write it down too. D equals M over V. So D equals the mass, which was 10.0 grams, divided by the volume, which is 5.0 centimeters cubed. And so 10 divided by 5 is 2. Now, these are 2 measured digits, 2 sig figs. These are 3 measured digits, so those are 3 sig figs, and I'm dividing, so my answer can't be more accurate than the 2 sig figs. So I have to say 2.0, and the units stay with it because density has a complex unit because it's mass over volume. So the density of that substance is 2.0 grams per centimeter cubed. Okay, second problem. Object has a density of 2.3 grams per centimeter, mass of 6.4 grams. What is the volume? So here's my given. I'm given the mass is 6.4 grams, and the density is 2.3 grams per centimeter cubed. What am I trying to find? Trying to find the volume. And so that's my question mark, that's my x. So I'm going to use this formula. Always write down your formula. D equals m over v. And I plug in the stuff I know. 2.3 grams per centimeter cubed equals the mass, which is 6.4 grams, divided by the volume. That's what I'm missing. Okay, so now I'm going to multiply v times 2.3 grams per centimeter cubed. Oh, my dog's barking. Can you hear him? Okay. It's going to be equal to 6.4 grams. Now I want this v. That's what I'm solving for, so I got to pull the 2.3 grams per centimeter cubed over. So volume is 6.4 grams divided by 2.3 grams per centimeter cubed. All right, grams cancel grams, centimeters flips up, and I get 6.4 divided by 2.3 gives me 2.8 centimeters cubed. That's the only unit left, which is my volume. Okay, so when you're doing a density problem, list out what you're given, what you're trying to find. Always write the formula. Always write the formula. All right. Always write the formula. And one thing I'll teach you in the next slide. Okay. So here's a review of what we learned. Matter has mass and volume. Yay, that's what makes it matter. Density is a property of matter and compares mass to volume and can be used to identify matter. All right. So if something is more dense than something else, it'll sink. Something is less dense, it'll float. We have to know how to get mass, balance. You know how to get volume, graduated cylinder, or measure and multiply. Know how to get density, D equals m over v. And then the other thing we learned was the law. All right. Matter can change, but mass stays constant. The law of conservation of matter, or mass, I'm sorry. And that 1 milliliter equals 1 centimeter cubed if we're converting. Now, I just want you to know you gotta love density. Gotta love density. Here's what I mean. You ready for this? Gotta love density. All right, D equals love. Density equals love. Now, if I draw a line right here, oh, look at this. This top part of the heart looks like an M. The bottom part looks like a V. Look at that. Gotta love density. Oh, yay. Cupid's little arrow. We gotta love density. Woohoo. All right, I'm done with the silliness. Peace out. Take notes. All right, know these objectives.